Back to my chemistry channel Reagent. In this video, I'm going to explain how to write molecular electronic configuration in C2 molecule, which is diatomic molecule, according to molecular orbital theory, which is valence bond theory. Only the molecular orbital theory can explain the formation of C2 molecule from two carbon atoms, so to form C2 molecule. When two carbon atoms combine their respective atomic orbitals, that means their wave functions overlap to form molecular orbitals. There are two kinds of molecular orbitals that can be formed. Bonding molecular orbitals which having lower energy and anti-bonding molecular orbitals having higher energy or excited state we say. If you look at this diagram of carbon energy levels if you observe, the arrow mark indicate increasing of energy level. So as you know that carbon having atomic number 6, so atomic orbitals are 1s, 2s and 2p orbitals it has. If you write the energy level increasing order, 1s having lower energy than 2s having lower energy than 2p. And if you write the electronic configuration, 1s having 2 electrons, 2s having 2 electrons, 2p also having 2 electrons. That means if you move from 1s to 2s, 2p, energy level increases. When two carbon atoms overlap, C2 molecule is formed. In the C2 molecule, there are two kinds of orbitals are formed, molecular orbitals we say. So these molecular orbitals, bonding molecular orbitals are indicated with the sigma star, pi star. When two carbon atoms overlap, they respective, for example, 1s orbital that having same energy, same symmetry will overlap on internuclear axis. When 1s orbital of one carbon atom, 1s orbital of other carbon atom that having electrons overlap on internuclear axis, two kinds of molecular bonding orbitals are formed, sigma star. During this time, electrons also redistributed first in the ground state according to Hund's rule and Pauli's exclusion principle. In excited state, 2 electrons, in the ground state 2 electrons. Similarly, 2s overlap, their respective electrons also redistributed into the bonding molecular orbital sigma 2s, 2 we can write. Rest of the electrons will go to sigma star 2s. And if you observe 2p overlap, 2p orbitals having 3 degenerate orbital, 2px, 2py, 2pz. So how the 2p orbitals overlap? If you consider one of the degenerate orbital, if you consider on the internuclear axis, that can form sigma bond. The rest will form the pi bonds. 2py, 2pz, if they form pi bonds, 2px will form the sigma bond. Vice versa. If you take if the 2pz taken on internuclear axis, 2px, 2py will form the pi bonds. Now, for example, here 2p2 of both carbon atoms having 2 electrons each, and now here is these electrons pair up in the ground state that can form 2p, pi 2py, pi 2pz, so electrons paired in this, and sigma 2pz not having any electron, pi star 2py 2pz not having any electrons vacant, and sigma star 2p also not having any electron. That means in the carbon C2 molecular orbitals, anti-bonding 2p orbitals, there is vacant orbitals are present, not having paired electrons, not having unpaired electrons. Hence, the magnetic character of the C2 molecule is diamagnetic, whereas O2 molecule is paramagnetic because of in antibonding there are unpaired electrons, but in case of C2 molecule there are no unpaired electrons in antibonding stage. There are electrons, paired electrons in the pi bond. And if you find out the C2 molecule bond order, we'll understand its stability. We understand stability of this. How can we write bond order? Bond order of C2 molecule, number of bonding electrons minus number of anti-bonding electrons upon 2. So how to find the bonding electrons and anti-bonding electrons? So now we can count in the bonding molecular orbital electrons 2, 2s2 and 4. So here you can write number of bonding molecular orbitals electrons are 8, and anti-bonding orbitals, if you take, there are 4, you can sigma star 1s2, sigma star 2s2, together 4, divided by 2, you can get bond order is 2. Between carbon-carbon, there are 2 covalent bonds are present. And remember, these covalent bonds are only pi bonds, not sigma bond. And C2 molecule exists in the vapor stage, not in the ground state. So this is the molecular electronic configuration of C2 molecule.